Hi, this is going to show you how we put a T5 Borg Warner transmission adapted to the back of a Chevy. This is a Ford T5. This is the world-class T5 removed from a 93 Fox body Mustang. So it has the Ford bolt pattern in the front, and then it has the Ford bearing retainer with the Ford 10 spline on the front. And so what we did was we bought a bell housing for a Chevy just small block first generation that goes from the engine to a Muncie 4-speed style. So this is the 4-speed pattern, and then Hot Rod Works makes an adapter to go from the Muncie 4-speed to the Ford T5 pattern. Now in order for this to fit, we did have to use a Chevy bearing retainer right here. So this is going to replace the Ford one. It's just slightly smaller, and so that way we can do a hydraulic throwout bearing later, and that way it fits into the adapter. Now for the pressure plate and the disc, we use just a generic GM 11-inch one, and then a 10 spline, just 11-inch clutch disc, and I'll put the part number for all this in the description below. Here's just some of the bolts and nuts for the adapter. As far as the throwout bearing, we're going to go with a hydraulic throwout bearing, and so we've got the kit here from who is this? American Powertrain. They use a Willwood style master cylinder, and then the slave, this is a slave that actually rides on the bearing retainer. So this is what the parts look like right now. As far as I can tell, the only thing that's not matching up is the pilot bushing. The pilot bushing is for the GM style, and so it just doesn't quite fit. So I'm either going to need to machine this or track down another one, but we'll see what we end up doing as we get a little farther along. So this is just the early stages, and I'll show you how it goes. Alright, I've got the S10 bearing retainer installed onto the Ford T5 transmission. I did have to cut the length a little bit. As you can see here, this is how much I cut off. The instructions from the Hot Rods Works kit will tell you, but it needs to be 3 5/8 inches from right here to right here. And so, getting ready to move on. Okay, so I've ran into the first problem so far. So installing this Hydromax throwout bearing, it requires this, which is just a guide pin. So basically you take one of the bolts out of your bearing retainer. So you remove this bolt, and then you're supposed to just screw this in, and then this rides alongside that, and it just keeps it from moving inside just a little bit. There's not a ton of pressure against it. The problem is the threading on this. You see it partially went in, but the threads are a little bit different. One of them's fine and one of them's coarse. So what I'll probably do is I'll probably just cut this off right at the threads and probably just weld it right on to the existing bolt. Like I said, there's not a lot of pressure on it. It just needs to be held in there. Now there's one other problem. I'm going to install this bell housing with the adapter on it. I'll install that onto the transmission, and I'll show you the second problem. Okay, so here's the second problem. This bolt needs to go in there. And you can see this aluminum makes it where it won't fit. And that was because they're expecting you to use this bolt here. There's a little like a pivoting bolt that goes on, and then you get your forks in from here, and then it pivots on that and operates your throwout bearing here. And since we're using the hydraulic throwout bearing, that's why we're running into these issues. So you could use a traditional linkage setup and make this work, but I'm pretty determined to make this hydraulic throwout bearing work because I just like the way that they feel, and I think that they last longer and they have less adjustments that are required. So we're going to make this work. We'll just machine out right here, probably just drill that, clean it up with a little Dremel or something, make it look good, and then we'll weld the bolt onto the little pivoting bracket, and then we'll put it together and it should work. Alright, here's the bolt. I'm going to have to just cut these threads off and then weld the new bolt on to change the thread pitch. Alright, here it is. I'm going to smooth down the heads of these a little bit so I can get a nice mating surface, and then I'll weld those together. Alright, here it is. I'm going to weld this up. Hopefully it looks alright. There it is. Now I just got to clean it up a little bit. Alright, here it is. I was going to sand it down a little bit, but I can still get my socket over it. And with that little bit of extra material, it's going to end up being stronger than if I smooth it all down. And so I'm just going to install that back right where this goes, and then this little part is going to be a little guide pin. Alright, this is how it looks mounted. The whole point of it is just that this can only move that small portion, because when the throwout bearing does make contact with the pressure plate, it does start spinning. There's a very small air gap between this and the pressure plate, but as it heats up, sometimes that is eliminated, or as the disc starts to wear out. But either way, there's just a very small amount of movement that's obviously taken up by the bearing, and so this is just a guide pin for it. And I did add a small amount of thread locker to it just to make sure it stays in there. Now ready to move on. So I used the drill press to drill out the area where this bolt goes, and then that way, let me throw the bearing release on, and that way, there it is. So it's locked into place, ready to go. Got the 4 shims, so we've got the distance all right. So now I'm going to mount the bell housing to the adapter, and then get the transmission ready to go up to the engine. Alright, when doing the automatic to manual conversion here, you're going to be replacing a factory flex plate with a flywheel. Now the flywheel is much thicker. You can see where it mates compared to the flex plate, which means the bolts are different as well. So the flex plate bolts look like they'll work, but they will not. So I just got a set of Mr. Gasket flywheel bolts. Alright, we've got the pilot bushing here back from my cousin. He machined it to within 0.02 of an inch over the input shaft. It came out just perfect. I mean, it spins freely, but it's got almost no play at all. And it'll be easy to slide right in. So, the next thing we're going to look at is we're going to look at how far the input shaft sticks out from the bell housing. You can see it sticks out just a little bit. So I measured it. We came in at 7 millimeter. So we want to make sure that we've got enough clearance on the crank over here. So when you're looking at this, let me see if I get a little light in there for you. So this sits inside here. It's going to get hammered in. And you see that little ledge that it meets. So from that little lip to this surface of the flywheel here is 51 millimeter. And then what I looked at was the distance between where the bell housing actually mates and the pressure plate, and we've got 42 millimeter. So there's a 9 millimeter difference there, and we've got the input shaft that sticks out 7 millimeters. So we know that once we hammer the pilot bushing into the crank, we know that it's going to stick out 2 millimeter farther. So it'll actually ride inside like this. So you see there is a little bit of extra room on the back, so we could have used the extended pilot bushing. So I'm going to add the part number in the description so that if you want to buy that, you can obviously do that instead of having to have this piece machined. But this will work for our needs. I may not hammer it in quite all the way to the crank, because if you notice, this is tapered. And so for the bearing to get the most surface area, just so that it wears nice and evenly, I probably just won't hammer it in quite all the way. So there you go. Alright, we're ready to install the clutch. I've got the pilot bushing installed, and so that was just hammered in very gently. And then I've got a tool here. This is a clutch disc installation tool. So the one that comes with the kits usually looks something like this. It'll be a 10 spline like this, but I got this from Speedway Motors, this whole clutch set, and it was a new product, but it didn't have the installation tool, which doesn't matter to me. I have the little adapter. So you put the adapter in there, and then you put the disc on, and then you slide this doohickey in, and that lines everything up. So what that's going to do is just keep the disc in the right place so that we can mount the pressure plate around it. It's pretty straightforward. You just put the pressure plate on. You've got 6 bolts, and I got new ones here. They're just Mr. Gasket new bolts. So we'll get this clutch installed, and then we can throw the transmission in. Okay, the next step here, we're going to be measuring the distance from the pressure plate to the transmission surface mount here. So we're going to be going from these little teeth on the pressure plate. We're measuring the distance from there to right here, the surface area. Now, I've already made that measurement, and then I've already taken the measurement on the transmission over here. For the transmission, you're going to take the measurement from the surface here of the throw-up bearing to right here. And so you look at it like this, it's going to be this distance right here. Okay, and the distance between those, you want to end up with 0.15. Oh, here they go. They've got their little description on how you want to measure it all out, but the magic number that we're looking for says not less than 0.1, not more than 0.2. We're coming in for 0.150 final air gap. I ended up using 4 spacers, and some of the spacers were a little bit mangled up, and so I put anything that looked a little bit off back in the bag. And with 4 of these shims, I ended up with 0.159, so we're exactly where we want to be. Alright, before we put the transmission in, I tightened up the pressure line that comes in the box. You just have to take off a little red cap. It's obviously a lot easier to do it now than it is to do it later. So the bottom one is going to be the pressure in. The top one is kind of cool. It's a remote bleeder. It's kind of like a brake line, so that you can make sure to get all of the air out of there so you've got nice fluid clutch travel. Alright, so it is ready to mate. So I'm about to grab this transmission and go throw it on the engine. Alright, here it is. We've got it all mated up. You can see these are the longer bolts that I use as guides. So I put them in there when the transmission is a little farther out, just so I can help guide it in. I did the whole thing by hand rather than the transmission jack, because it's a pretty light transmission, and it's good to just wiggle it in there nice and carefully. You don't want to hammer it. You don't want to use these bolts to force it in. The biggest issue is usually lining everything up with the pilot bushing, because the clutch disc inevitably will move just a small amount, and that can kind of draw your transmission input shaft just a little bit and make your pilot bushing just a hair off center. And so you really just kind of got to wiggle it around, wiggle it around. What I have done before, with a more traditional style spring-loaded clutch or linkage clutch, when it's still on the vehicle, if you get the bolts to where it's like within a half an inch or so, and you have the bolts in, but everything's still kind of loose, you can push in on the clutch, and it'll release the pressure plate, and then the disc will spin freely, and that'll help move the disc just a hair to line up the input shaft with the pilot bushing. But that's just a little trick. But basically, don't get frustrated. Just keep working at it nice and slowly. Wiggle it in there. You'll get them to mate. And then we get it installed in the vehicle, bleed the lines, and then test it out. So this is kind of cool to take a look at. There's our hydraulic throw-up bearing. You can see it's still on there. So you see how close it is to the teeth right there. So the number we're looking for is 0.15 inches. 0.125, that's an eighth of an inch. So we're looking at just a hair more than an eighth of an inch is the gap that should be there. And boy, that looks just about perfect. So it's pretty much done. It's ready to go. It's going to be a little while before I can throw this on the vehicle. So I think I'll finish here, and then I'll do a part 2 where we basically bleed the system and then drive it around. So that'll be a couple weeks from now, but I'll get this up now. Thanks for watching. So here's the alternative to welding up that stud carrier. They make this sleeve with a stud carrier built in. It wouldn't have worked for us because it is a little bit too thick. We only used 4 shims, so that would have been too thick. This is more for other transmissions if you need to clock the position slightly different. So instead of welding it up like I did here, what I'll do next time, I'll take a bolt like this, I'll cut it off, at whatever length you want that stud carrier to be, and then you just finger tight it in, maybe with a little bit of medium Loctite, and then once it's in, you can just tighten down the locking nut. So that would have made a lot more sense. I might still pull the transmission off and put a different one on there just for fun, but that's a way to do it without welding, so hope that helps.